Is the screen visible?
Yes, ma'am.
Okay. So, good morning, everyone. In the yesterday's class, we have begun with the module number 3. So, there we have studied about the basic concepts which we have already studied in the module number 1. How the data is transferred between the processor and the memory with the help of the memory address register and the memory data registers. So, after that, we have also studied about the MFC signal, that is memory function complete signal, which is generated when the data is provided by the memory and it is loaded into the MDR. So like this, the what you can say, the transfer between the processor and the memory is taken place. This we have seen in the yesterday's class. So today we will be after that we have also seen what are the different concepts like memory access time and memory cycle time. Memory access time means it is the time between the initiation and between the MFC signal, the time between the operation initiation and completion of that operation. So that is the memory access time. What is the memory cycle time? Time between the two different successive operations is called as the memory cycle time. And about random access memory also we have seen. And how can we increase the performance of a system by using a cache memory and also the virtual memory. These are the concepts we have studied. Also we have started with the semiconductor RAM memories, its internal organization we have studied here with this block diagram, where each of the cell is acting like a switch and it is storing only a single bit, a 0 or 1 here. Then how do we select each of the row and each of the columns using this sense and write circuit, and we are displaying the output on these input and output data lines from B0 to B7. So this organization is of 16 into 8. So like this we can have a larger scale where we are having a 32 into 32. So like this we have seen this block diagram. Then we have started with the static memories. So each of the cell, how it is organized, we have studied here, where two inverters are connected crossly connected to form a latch. Latch is used to store the data into it, and these latches are connected to the transistors T1 and T2, which in turn are connected to the bit lines, that is B and B dash. These transistors are left open to store the data. If these transistors are closed, how they are closed? By activating the word line. When the word line is activated, the transistors are closed and the data which is present in this circuit is displayed on B and B bar. So this we have seen how to read and write. Then next today we will be starting with the asynchronous DRAMs. So asynchronous, see now whatever we have seen here, this is static RAM. Okay, it is a static RAM. What is the main property of a static RAM? What do you mean by static? Yesterday only I have told. What do you mean by static? Yes, anybody? What do you mean by static RAM? What do you mean by static RAM? You can answer in the chat box also. Static RAM means whenever the data is, whenever the power is gone, there is a power cut off. That time what will happen? The RAM will lose its data, the memory will lose its data. That is called as a static RAM, is it not? So when the power is taken off, when the power cut takes place, that time the data which is stored into the memory will be lost. So we are going for dynamic RAMs, that is DRAMs. And in that dynamic RAMs also we are having two types, that is synchronous and asynchronous. So today we are going to study about the asynchronous DRAMs. We are going to study about the asynchronous DRAMs. What do you mean by asynchronous? Tell me. Asynchronous. Okay, before that, tell me what is synchronous then. This we have studied already, is it not? See, synchronous means the everything data transfer takes place with the help of the single clock signal. Okay, a single clock signal will govern the data transfer between the processor to memory or memory to processor. Single clock signal. But in asynchronous, what will happen is there is no common clock signal there. Everything is done by different control signals. Okay, data transfer from the memory is done by different control signal, data transfer from the processor is done by different control signals. Everybody will work separately, individually, on their own, so they are called as asynchronous. And why they are called as dynamic means they are retaining the data here. Let us see how we are going to do here. Initially, whatever static rams, so one very important advantage of the static rams is the data transfer is very fast. Static rams are very fast, but they come in high cost. Why they come in high cost? Because they are requiring the several transistors. So if we are replacing some of these transistors, then the cost can be reduced. So how to reduce that? By using this dynamic rams. So in the dynamic rams, few transistors are replaced with the capacitors, so as to reduce the cost of that particular rams. Okay, the cells do not retain their state indefinitely, so they are called as dynamic rams. Okay, they are how they are not retaining, or how they are retaining the data present into it, let us see now here. So here we are having a diagram of a single cell here. So we have seen a diagram of a single cell here in the place, in the terms of a static ram cell. So now here we are having the dynamic ram cell. So what is the difference? What is the difference? Can you make out here? There two transistors are used here. Two transistors are used, but here only one transistor is used. Another transistor is replaced by the capacitor. This capacitor will what it will conduct the charge. This capacitor is responsible for maintaining the data. For retaining the data into the cell, capacitor will work. Okay, then everything else is the same. We are having a bit line, we are having a word line, we are having a transistor and a capacitor. The charge on this capacitor, if this capacitor is fully charged, then the data present in this cell will be retained. If the charge is discharging, then whatever data is there, it cannot be retained. So, and this charge can be maintained when the transistor is on. How this transistor can be made on? By applying the word line. Okay, when we are applying the voltage to the word line, the transistor is turned on. When the transistor is turned on, this capacitor will be charged to its full extent. Okay, when the transistor is on, that time the capacitor will be fully charged. When it is fully charged, that time the data present, the data present into the cell can be retained here. Now when this transistor is turned off, that time what will happen? Slowly the charge on this capacitor will start to discharge. The charge on this capacitor will start to discharge, and that time what will happen? How it will discharge? Because this capacitor will be having its own leakage capability. So because of the charge leakage capability, the capacitor will start discharging. This is one point. Another point is the transistor will be also using the very small picoamperes of current. Pico means very small. Okay, like we are having milli, micro, like that. Pico we are having unit. So small amount of current is also utilized by this transistor when the transistor is turned off. These are the two reasons how the capacitor charge will be discharged. So when it is going to discharge, that time what will happen? Whatever data is stored into the this cell will be lost. So how to avoid this? So for maintaining the data which is present in the cell, we have to keep on refreshing this cell periodically. Okay, this cell has to be refreshed periodically. Now see here, information is stored in the dynamic cell in the form of a charge on the capacitor, and this charge can be maintained only tens of milliseconds. Means what? This charge can be maintained for a very small amount of time. So how to maintain this for a large amount of time is by periodically refreshing and storing the capacitor charge to is full. How do we refresh? That is the next point. But for now you have to remember that the data which is stored in the cell is maintained in the form of this capacitor charge. Okay, so when the capacitor is fully charged, the data is maintained in the cell. When the charge on this capacitor starts to discharge, that time data might be lost. To avoid this, we are going to refresh this capacitor to restore the charge on it. Understood, all of you? Have you understood this one? Yeah, tell me, have you understood? See, your voice will not be audible all the time, so you can drop a message in the chat box every time I do tell this one. Okay, you have understood. So next we are going to see here this example we have seen here of a single cell we have seen. That single cell that is modified, and we are keeping here in the form of 4k into 4k array. Okay, 4k rows and 4k columns. Means 4k means 4096 cells. These cells, this is the one cell. Okay, this is the organization of a single cell, a single transistor dynamic memory cell. This is a single cell. So like that we are having 4096 cells in each rows and 4096 cells in each columns. 4k means 4 kilobytes, means what? 4096 cells in each row, and in each column we are having 4096 cells. How these 4096 cells are distributed? Each row is containing 4096 cells. See in this block diagram here, each row is containing 4096 cells. But how about the columns here? So in the columns we are having 8 groups. These 4096 cells in the columns, they are divided into 8 groups. Each group is having 512 bytes of data into it. 512 into 8 will give you 4096. So there are 4096 rows. Each row is having 8 groups, each having the 512 bytes of data. Okay, so here what they are saying, 4096 cells in each row are divided into 512 groups of 8. Means the row can store 512 bytes of data. Each group can store 512 bytes of data into it. So to address this much, we are requiring 21-bit address. Okay, so here we have seen how only 4 bytes of address, 4-bit address we were requiring. Here 4-bit address were requiring. Here when we increased it into 128, the time 10-bit address was requiring. Is it not? 10-bit address was requiring. In the similar manner, here we are having 4096 cells. For that, 21 bits of addresses are requiring. So among these 21 bits, how again it is segregated is, out of these 21 bits, 12 bits are required to select one complete row. When you are selecting a complete row, means 4096 cells of all that row will be selected. Okay, so now here what we are having, we are having an arrangement of 4k into 4k array. Means 4k rows, 4k columns. 4k row means it is having 4096 cells. Then in 4k columns, each is divided into 8 groups. Each 8 group is having 512 bytes of data. To access these data, we are having 21 bits of address. Of these 21 bits, 12 bits are used for selecting a complete row. 12 bits are used to select a complete row. Out of that complete row, we have to select which group. There are 8 groups, no? There are 8 groups. Why we are selecting only 8? Because I am having the output data as only 8 bits here, D0 to D7. I am having only D0 to D7, 8 bits of data I am having. Is it not? So that is why which group to select out of 8 group, which group to select. To identify which group to select, we are using the 9 bits 9 bits address. Okay. So the higher order 12 bits are indicating the row address, and 9 bits lower order are indicating the column address. So using these two, that is 12 bits for row, 9 bits for column, we are selecting the row and column. Let us see how is the arrangement of this block diagram. Here two special signals we are having called as RAS and CAS, that is row address strobe and column address strobe. Row address strobe are, these both are active low. They are following the negative logic. What do you mean by negative logic? Can anybody tell me fast? What do you mean by negative logic? Anybody? I have told this many a times. Fast. What do you mean by negative logic?
When it is zero, it is active.
Yes, very good, Srishti. So, negative logic means these signals are active in the lower edge. When it is 0, it is active. When it is 1, it is inactive. So, this is the negative logic. They are called as active low signals. Active low means these signals are active for the low signals. Okay. So first and foremost, we are giving the row address here. Okay, we are giving the row address by using the 12 bits. So that 12 bits is given as a row address here. A9 to 20, 12 bits are used for giving the row address. How the row address is stored in this row address latch is when this row address strobe RAS signal is generated. When the RAS signal is active, that time the row address is latched into this block. This is row address latch, means the address is stored. Latch means what? Latch is used to basically retain the state. Okay, latch means it is used to retain the hold that particular data which is present into that block. Okay, so am I audible, students? Am I audible?
Yes, ma'am.
Okay. So when the RAS signal is generated, that time the row address will be latched into this block. This row address will be given to the row decoder. So when the row decoder will decode that row address, that particular row will be selected. Complete row. That particular complete row will be selected. Now I have selected the row, but in a row, how many cells are there? There are 4096 cells. But out of 4096 cells, I want only the data from D0 to D7. In the sense, only 8 bits of data is required. So there are 8 groups, is it not? Out of these 8 groups, which group to be selected? That is again given by this column address. Okay. So the column address, when the CAS signal is, that is column address strobe is active, that time the column address is generated and latched into this column address latch block. Once the column address is given here, it is also decoded. Then row already we have selected. In that row, which particular column is to be selected? Which particular 8 groups, which 8 bits of data is to be selected? That is given by this column address decoder. So the when it is decoded using this sense and write circuits. What is this sense and write circuits? Sense means it is reading, write means we are using it to write the data. Now I want to read the data. So to read the data, sense circuits is used. Sense circuits senses the data which is given by this at the given row address and the column address, and the CS signal. What is CS? Chip select signal. That only 8 group, by when we have specified this column address. So when we have specified the column address, only that 8 groups, 8 bits of data will be selected, and that data will be then given on to this output line, that is from D0 to D7. So what is the difference we are having here? We are having only the RAS signal and CAS signal and the latches which are used for storing or retaining the row address and the column address. Now I told you that this is a dynamic RAM. When the dynamic RAM is used, the capacitor should be charged periodically, is it not? So how it will be charged then? By accessing that row. When you access a row, when you read that row, automatically the data will be restored, means the capacitor will be charged. So when you are restoring the data, that particular row will be charged automatically, refreshed. That particular row will be refreshed just when you read the data from it. Okay, when you are selecting the complete row, but you are reading only 8, one group you are reading, other all 7 groups will not be read, is it not? For that particular, to do that particular thing, we are going to use a refreshing circuit there. Okay, we are going to use the refreshing circuit so as to refresh the complete row. All 512 bytes of each group will be refreshed by a refreshing circuit. So mainly we have to remember in these dynamic RAMs that we have to refresh that particular cells to maintain the charge. To refresh it, what you are doing? We are going to read the data of that complete row. If the data is read, then automatically it will be refreshed. So we are using a refreshing circuit here. Now here see, only one group among the 8 groups is selected. So we have to select each of the group here. First group should be first 8 bits, second 8 bits, third 8 bits, 4 8 bits, like this. All the 8 bits of data of all the groups should be selected for refreshing. So how to do that? That we are going to study in the fast mode. So we are going to study in the fast page mode. Till here, have you understood till here, all of you? Have you understood till here? Have you understood this block diagram? Okay, next we are going for the fast page mode. So what is this fast page mode? Is this fast page mode is mainly used for this one is first main important thing where we are using fast page mode is uh, uh, to make the reading or writing faster, first thing. Second thing is for refreshing the complete row. Here what we are doing, just we are reading one row, we are taking out of that row only 8 bits is used, that 8 bits will be refreshed. Okay, so if you want to refresh the 8 bits of next group, again we have to take that row address, then again we have to refresh that second group. So suppose we want to refresh the third group, so again you have to read the row address, then refresh the third group. So each time you want to refresh the group, you are reading the row address again and again. To avoid this, what we are going in this fast page mode. So in this fast page mode, what will happen? Only once the row address will be used here. Only once the row address will be used, and that will be latched. That will be latched so that when you are going to refresh the next group, simply whatever the address was generated previously by this row decoder, that address is used. Here again the address of the row is not specified. The address of the row is not specified here again. So only the address is given one time, first time when the address is read, that address is stored in this latch and it is decoded only for the first time. So for the second time, what you are going to do is directly the address which is decoded by the row address, that will be taken and it will be refreshed one by one. So one by one means what, we have to have maintain the sequence sequentially. If we start all sequentially means from first group, second group, third group, fourth group, like this sequentially, if we start once the row address is given, first group of column, same row address, second group of column, same row address, third group of column. So like this sequentially we are going on refreshing. So for that we are going to use a counter here. We are going to use a counter, row column address counter, in which automatically the sequential groups will be selected. So for the same row address, first 8 groups, for the same row address, second group. So for that I don't have the block diagram here, but in the next class I'll be showing you the block diagram of that fast page mode. Okay, so we are using a counter there. We are using a refreshing column counter, which will give select the column address of each group sequentially. So like this we are using for refreshing the complete row. When we are refreshing the complete row, automatically the charge will be stored into it. How the charge will be, see, I am telling periodically it should be refreshed. Sometimes what happens that refreshing will not happen. So how it will, how to find out whether the charge is there or not? For that what we are having, we are having a circuit. So we are having a control circuit here. See, during a read operation, here you can see, during a read operation, charge on the capacitor drops below the threshold value. For that we are having one sense amplifier circuit. Sense amplifier circuit, what it will do is, it will find out whether the charge on the capacitor is above the threshold level or below the threshold. What is this threshold value? What do you mean by threshold? Yes, tell me, what do you mean by threshold? Threshold is some like average value or some like minimum value it is. Okay. So whenever the charge will drop below this threshold value, that time the data cannot be stored into it. The data will be lost. So there is, during the read operation, the transistor in the cell is turned on, and it is turned on means what? When it is turned on, when the bit line, whenever the word line is supplying the voltage, this transistor will be turned on. Then there is a sense amplifier circuit. This sense amplifier circuit will check whether the charge on the capacitor is above the threshold value or it is below the threshold value. So first point, when the charge on the capacitor is above the threshold value, that time the value of that circuit will be equal to value 1. Okay, when the charge on the capacitor is on the when the charge on the capacitor is above the threshold value, that time what will happen? The bit line will drive to the full voltage. Okay, so here we are having the word line, no, bit line and word line. So this bit line will provide the voltage and this capacitor will be driven to the highest voltage. When it is driven to the highest voltage, it will represent a value 1. So when the charge on the capacitor is above the threshold value, that time a value 1 is predicted. But when the voltage discharges and it is below the threshold value, when it is below the threshold value, when the sense amplifier, when this sense amplifier will find the charge on the capacitor below the threshold value, when it will find the charge on the capacitor below the threshold value, that time what will happen? The bit line, whatever this bit line is there, this bit line will pull down the charge on this capacitor. When it will pull down the charge on the capacitor to the ground level, then a 0 will be stored. When it is above the threshold value, the value is 1, and when it is below the threshold value, the value of that cell will be taken as 0. Okay, so like this we are going to read it. So how to read? By using this sense amplifier circuit. So when you want to maintain the charge on the capacitor, we have to go to the refreshing, we have to go to refresh. How do we refresh? See, all the cells in a selected row are read at the same time. See, when you are doing the read operation, that time automatically refreshing of that complete row is done and the data is maintained. Okay, so how the refreshing is done, that we have seen here. So in the next class we'll be studying about the asynchronous. Okay, we'll be studying about asynchronous DRAMs. Okay. Is there any doubt till here? We have completed the dynamic RAM cell organization and also its block diagram. Asynchronous will be studying tomorrow. So what is asynchronous? Basically here everything in this asynchronous, everything is done by the different control signal circuits. There is no common clock signal here. Okay, so here in the dynamic RAM, timing of the memory device is controlled asynchronously. Asynchronously means individually. By each of them, they are having their own timing signals. They are not depending on a common clock signal. So we are having, each of them are having its memory controller circuit. Each row address is generated, column address is generated, it is decoded, data is selected by the sense circuitry. Each of them are having their memory controller signal individually. Their memory controller signal will generate the control signals for them only. Like for row address signal will be generated by its controller circuit, column address will be generated by its controller circuit. Each of them are having their individual timings, so it is called as asynchronous. So but next we will be studying the synchronous. What happens in synchronous is, there is a common clock cycle. Under this common clock cycle only all the data transfer will happen. So we will be studying that in the next class. So till that, all of you start reading. Okay, just wait, I'll take the attendance, then you can leave the meeting. Others is present. Aditya Pawar,
Yes, madam.
Anuradha,
Yes, ma'am.
Bharat,
Yes, ma'am.
Bhavna,
Yes, ma'am.
Dada Saheb, Dhanashri,
Yes, madam.
Srushti, Janhavi, Gayatri,
Present, ma'am.
Maithili,
Yes, ma'am.
Pratiksha, Niyaz, Pooja Biradar, Rashmi,
Yes, ma'am. Yes, ma'am.
Kamath, okay, present. Rohan Shedge, absent. Rupesh, present.
Yes, ma'am.
Ruturaj, present.
Yes, ma'am.
Samiksha, Tahshildar. Sanket Jadhav,
Yes, ma'am.
Swapnali, Tippe Abhishek,
Yes, madam.
Sumit, Unhale Sumit,
Yes, madam. Yes, madam.
okay. Vidya Kesarkar, Vidya not there. Vinod,
Yes, madam.
Junaid, Shubham Katkar, Shubham Katkar, Solomon, Yusuf, Sharmila, Srivats, Venkatesh. Venkatesh, are you there? No. Okay. All of you can leave the meeting now.